Listen, I tried to make an entertaining intro for this video, but it didn't work, so I will cut to the chase. Now, this video is about the Mini Shai-Hulud supply chain attack. I managed to trick an AI agent to recreate it for me. It was not hard, it is very easy. Actually, the AI agent recreated it for me so that I can understand it, and I'll do my best to help you understand what happened here so that you can get into the mindset of looking into the details and being a little bit um, uh, a little closer to being safe online, which is not really possible, but you can do your best to be as safe as you can. Now, what happened is that before what happened, what is the Mini Shai-Hulud supply chain attack for those who don't know? Now, exploits were a thing before AI agents, they're a thing with AI agents, and they will be a thing after AI with the next ultra hype thing that happens, be it quantum computers or whatever. Exploits will always be here. There will always be groups and people who want to exploit technology. This is how life works. This is our reality, and this is okay. I mean, it's not okay, but it's fun, right? Every one of us, when we start doing computer tech stuff, we want to either be game developers or hackers. So the point is that exploits happen. And last week, one of those exploits got a little bit more viral online. What happened is that Tanstack, which is a pretty famous project, got found, it got hacked by a group called Team PCP. Now, what they did is they managed to make their way through one of their repositories in GitHub. From there, they we'll talk about this. Did a trick called cache poisoning. They poisoned some cache, which allowed them to get some OIDC credentials and essentially have access to the entire ecosystem of Tanstack. How this happened is, in my opinion, not complex, but it is very clever, and it abuses exactly this lack of attention to detail. The first thing that we're going to look at is the demo of how it happened. Let's imagine that this repository here is the Tanstack repository that got pwned, that got compromised. What they did, Team PCP, is they opened a pull request in this repository. Opening the pull request triggers a workflow, which workflow has the pull request target trigger. This is the first pebble or the first stepping stone to ultimately the end result of Tanstack being hacked. Why, you may ask? Well, the pull request trigger, if we look at GitHub's official documentation, states that this event runs in the context of the default branch of the repository rather than in the context of the merged commit, as the pull request event does, which, when combined with the fact that the pull request target workflow that Tanstack had executed forked code, means that any malicious code will be executed against the context of the base branch. And this is exactly what happened and what we are doing here in this demo. I am opening a pull request from a person called Spacey Leon. This is coming from Lazy Peon from World of Warcraft, and he's saying a very useful pull request this is. When this happens, there are two workflows being triggered. Now, the commit that you're going to see, this sketchy account made against our repository, is updating the package JSON of our project, and it is adding a post install script that is running a script they wrote and committed to the pull request. Now, what happened in the Tanstack attack is that they did not commit the malicious code, but instead just referenced to it in the post install updated key value pair here that you're seeing to point to an external website and execute the malicious script. When the script was executed, the following thing happened. There are two workflows that took place. The first one being the pull request target, which does the npm install, produces a node modules, and it runs a step in the workflow called actions cache save. And now, since this pull request target triggered workflow is running in the base branch context of the repository, this means that a trusted release workflow later that is running from the base branch was able to restore cache poisoning, to restore the cache that they saved through the malicious pull request. This is essentially what cache poisoning is. The cache is something that you would trust, and trusting the cache means that your system doesn't need to double check what is going on inside of it because, well, it is cache after all, you know? But in this case here, the cache was not well separated and they poisoned the cache, essentially making it so that when they run the trusted release workflow, as we are doing here in the release report workflow, they executed this malicious code in the main branch and with the permissions that allowed the trusted workflow to do changes, to release something. In my case here, we are doing this through the restore dependency cache step. This means that the compromised code, the malicious code that was included in the pull request, triggered this second workflow after the first one, and we executed the malicious code with the npm install command here because we have the post install script. Guys, I actually lied here. It's not the post install script that does the work because we have ignore scripts, and not only, but the npm install is entirely being skipped because there is cache present. So essentially what happened is that the updated left pad package from the repository, from the malicious pull request, this is what updates the left pad package, is then being executed through the release nodes step, which actually includes the left pad package. But since it was restored from the malicious pull request, it is being executed in its updated version, essentially doing everything bad that it does. Yeah, just wanted to make this clear. It is not the post install script. It is actually the release step that is either way being executed. It's just that it restores the vulnerable left pad updated package and executes it instead. Just want to make this clear. Continuing the video. Now, what the change was, you can see in the pull request, is that it is the attacker is just rewriting some of the logic of one of the packages that was used in the release nodes step. The package here, just for the sake of the example, is left pad, and they are changing it so that it commits a new file and pushes it directly to main. Now, if we see the project's, the repository history, we will see that the left pad was committed here. hehe.txt just proves that the exploit worked. Now, this exploit, why do I think that it is not complex? Because it is not abusing some, it is not requiring some super hard, some super complex logic for it to work. It just abuses the negligence of details from TANStack to use the pull request target allow to execute forked code and then trust the cache from this executed forked code and run the release workflow. So this is pretty much about it. I think it is really nice using AI in ways to help you learn, understand how things work, especially when those things are exploits and, well, dangerous supply chain attacks, you know? Um, But yeah, what I'm trying to say is that AI is here, and while it is kind of annoying to prompt the entire day, if you put in effort in what you're doing, it can help you a lot. Because what better way to learn about something than to have a live example that you can morph into any shape you want through just asking the AI to do it. And then you can ask it to explain it to you and to do web searches. And then you can explore the concept with your own personal teacher, you know? So thank you for watching. Stay safe out there and don't let your workflows let attackers steal your credentials, I guess. I don't know. Have a good one. And by the way, if you like reading more than watching videos, I highly doubt that. Anyway, I have a blog post about this with all the architecture diagrams as well. So if you want to read that, you can find it in the description below.